Welcome to today's ArXiv CS Digest for March 30th, 2026. We received 705 new computer science papers today across 53 subfields. Let's dive into the top picks. Trend 1 of 5. Mathematical structures for advanced computing. Applying diverse mathematical structures to fundamentally advance and optimize various computing paradigms. This cluster covers 147 papers. Representative work includes adaptive block-scale data types, geometry-aware similarity metrics for neural representations on Riemannian and statistical manifolds, and fast large-scale model-based iterated tomography via exploiting mathematical structure, hierarchical optimization, smart initialization, and distributed GPU computing. Trend 2 of 5. Generative AI for diverse applications. Leveraging generative AI, particularly LLMs, to address complex challenges across various scientific, technical, and humanistic domains. This cluster covers 171 papers. Representative work includes graph philosophy, graph-based digital humanities computing with the 4 books, rethinking language model scaling under transferable hypersphere optimization, and RADEI, rethinking architecture documentation for AI-augmented ecosystems. Trend 3 of 5. Secure and resilient digital infrastructure. This trend unifies efforts to enhance the security, privacy, and resilience of digital infrastructure, spanning hardware, protocols, and applications. This cluster covers 108 papers. Representative work includes Iran's January 2026 internet shutdown, public data, censorship methods, and circumvention techniques, hidden yellow, private matchmaking through encrypted rating systems, and study of post-quantum status of widely used protocols. Trend 4 of 5. Advanced generative AI for vision. Advancing generative AI for vision to enable controlled creation, diverse outputs, and multimodal reasoning and action. This cluster covers 139 papers. Representative work includes Gen Searcher, reinforcing agentic search for image generation, on-the-fly repulsion in the contextual space for rich diversity in diffusion transformers, and Apple, attribute-preserving pseudo-labeling for diffusion-based face swapping. Trend 5 of 5. Human-robot interaction and motion. This trend unifies research on perceiving, predicting, generating, and controlling human and robot motion and their interactions in diverse settings. This cluster covers 140 papers. Representative work includes HandX, scaling by manual motion and interaction generation, Vipra, video prediction for robot actions, and PoseDreamer, scalable and photorealistic human data generation pipeline with diffusion models. Up next, our first paper out of 5, AgentDrift, Unsafe recommendation drift under tool corruption hidden by ranking metrics in LLM agents by Ziken Wu and Maria Perez-Ortiz from Center for Artificial Intelligence, University College London, Holistic AI. Let's break down its key contributions. This core experimental design replays financial dialogues under clean and contaminated tool output conditions. It systematically analyzes agent behavior divergence, uncovering safety failures hidden by standard evaluation metrics. Up next, our second paper out of 5, Observable Channels, Not Just Storage, Evaluating Privacy Leakage in LLM Agent Pipelines by Tao Huang and Jiayong Meng from Minjiang University. Let's break down its key contributions. This paper redefines privacy leakage in LLM agent pipelines as a channel inversion problem. This novel formulation moves beyond specific system components, enabling a more generalized understanding of how hidden dependencies become observable signals. CIPL introduces a target-independent framework to represent any LLM agent system through a common signature. This signature comprises sensitive source, selection, assembly, execution, observation, and extraction stages, providing a unified view for analysis. CIPL provides a reusable attack language to instantiate attacks against diverse LLM agent pipelines. This language consists of a locator, an aligner, and a diversification policy, enabling flexible and systematic attack construction across different targets. As a unified evaluation framework, CIPL supports systematic cross-target comparison of privacy leakage while preserving target-specific execution semantics. This allows for consistent measurement and understanding of risk across heterogeneous agent pipelines. Up next, our third paper out of 5, Combinatorial Privacy, Private Multi-Party Bitstream Grandson by Hiding in Burkhoff Politopes by Praneeth Vepakama from Mohammed bin Zayed University of Artificial Intelligence and BZUAI. Let's break down its key contributions. Polyveil introduces encoding private bits as permutation matrices within the Burkhoff polytope. This foundational component allows for private Boolean summation across multiple clients, forming the core data representation. A two-layer architecture provides perfect simulation-based security for the server, achieving statistical distance zero. This design ensures the server cannot infer private data, enhancing overall protocol robustness. The full variant exposes a doubly stochastic matrix per client to the aggregator, leading to #p-hard likelihood inference. This leverages the permanent and mixed discriminate for strong computational privacy guarantees. The compressed variant simplifies the aggregator's view to a single scalar, enabling non-vacuous differential privacy at moderate SNR. This balances CLT accuracy against noise concentration for practical privacy. A finite sample, epsilon, delta, DP analysis with explicit constants is developed for both variants. This rigorous evaluation quantifies privacy guarantees and highlights the fundamental tension between variants. Up next, our fourth paper out of 5, Crossing the NL/PL Divide. Information Flow Analysis Across the NL/PL Boundary in LLM Integrated Code by Zaheo Su and Yuekong Lee from University of New South Wales. Let's break down its key contributions. This contribution introduces a novel taxonomy with 24 labels, categorizing information flow across the NL/PL boundary based on preservation level and output modality. It provides a principled framework for understanding LLM integrated code. This method applies the taxonomy for filtering in a two-stage taint propagation pipeline, combined with LLM verification. It effectively tracks data across the NL/PL boundary, achieving high accuracy in real-world scenarios. This contribution leverages the defined taxonomy to inform backward slicing, specifically identifying non-propagating placeholders. This significantly reduces slice size, improving the efficiency of program analysis in LLM integrated systems. Up next, our fifth paper out of 5, Reward Hacking as Equilibrium Under Finite Evaluation by Jiaqing Wang and Jinbin Huang. Let's break down its key contributions. This foundational component establishes 5 minimal axioms: multidimensional quality, finite evaluation, effective optimization, resource finiteness, and combinatorial interaction. These axioms define the problem space for analyzing AI reward hacking. The framework instantiates the multitask principal agent model from Holmstrom and Milgrom, 1991, within the AI alignment context. This provides a robust economic lens to analyze agent behavior and incentives. This contribution leverages the differentiable architecture of AI reward models to derive a computable distortion index. This index predicts the direction and severity of reward hacking on various quality dimensions before deployment. The paper analyzes how the transition to agentic systems causes evaluation coverage to decline as tool count grows. This demonstrates that hacking severity structurally increases without bound in complex AI environments. This contribution conjectures a capability threshold where agents transition from gaming within the evaluation system to actively degrading it. This provides an economic formalization of the treacherous turn concept,